So here are our polarity positions right here. No, that's not polar because it's equally spread across the molecule. Yes, this is polar. And one thing that might help with all of this would be if we go ahead and we pull in these shapes here, and we'll look at them too. So the seesaw shape, what we're saying is that, yeah, they're the same atoms. They're all Fs, but everything wants to be near the F. It's like super popular. So it's saying our negative charges, are all kind of like hanging out right by that F atom. It's like the electrons in the bond are all over on his side. And notice there's nothing on top. You can see that there's like no balance for them. And so one side's going to be slightly negative, which does make it polar. And then again, if we look at this picture, this is slightly negative and this is slightly negative. If this were, again, you can see that the negative charges are on one part of the molecule, and then there's not much on the other. And let's see. So the picture for this one right here would go back to the very top. So if we kind of look at a picture like this and we just pretend that those are single bonds, yeah, there are electrons all around the edges, but this is a linear shape. And those electrons are actually, if you kind of think of a triangle going around it, in a different plane of the page, like this part is coming towards you and this part's like behind your book, those electrons are evenly spaced. And so if you have a little bit of negativity over here and a little bit over there, they're evenly spaced and it's okay. Sometimes if there's always two exceptions for when things that have all the same atoms and they also have lone pairs, but they turn out to be nonpolar. And there's two exceptions where they turn out to be nonpolar, and this is one of them. So you might just put like a big star here. And then again, all these atoms on the outside, if you look, if the electrons are kind of over here in that bond, all those negative electrons, but they're evenly spread. They all have like a match on the outside. They're evenly spread across the molecule. You're okay. That is nonpolar. And then, and actually this was supposed to be in here. But this one right here is here. And again, spread it out across the molecule. So that is polar. Now this one is the other funny exception that you're going to want to put a star in. So if you just look at those electrons, you can see that they are evenly spaced. But you might be saying, what about the lone pairs? Okay, the lone pairs are above and below the molecule. So the above and the below also balances it out. So that's not polar overall. Now go ahead and try to finish out the next two. And by the way, double bonds aren't seen as generating an excessive amount of there's not something that's extra special about that angle when it has resonance and it's spread all around that molecule.